All right, we are in day 5, part 2. So we are going to go and discuss absolute convergence versus conditional convergence. They're like, Mrs. Wimmer, what the heck? How can there be more than one way to converge? If you converge, then you've got something, right? Okay, well, no. So the short answer. So absolute convergence means no matter what, you always converge to the same number. Conditional convergence says I can do something and still mathematically be a correct thing that I've done, but yet I can converge to a different number. What? Okay, so that's kind of cool, and that's what we're going to talk about today. Divergent, divergent. Okay. So here it says, explain why if the series converges, then the series also converges. So what are we seeing here? We're seeing the absolute value bars, and that's what we're talking about when we get to absolute convergence. Means we're going to take the absolute value bars, get rid of any negative signs, and see if that series converges. Then we're absolutely convergent. Okay, so let's go see. So definition here. Oh, I just saw a typo. That should say convergent. I'm going to have to fix that for you guys. Okay. Oh, come on. Use. Okay. So that should say convergent. There is no absolutely divergent, absolutely divergent, divergent. That I just saw that. I will get it fixed before I print for you. Okay, so the definition here. A sub n is absolutely convergent if the absolute value of that converges. So meaning that all of the negatives got taken away. We are doing term by term with just all positive numbers, okay? So each individual term turned positive, and if that series now converges, then we say this one is absolutely convergent, okay? Conditionally convergent means this was a convergent series. The absolute part of it diverged, but it still was a convergent series to begin with. That's conditionally convergent. Okay, so let's look at this first example. It says determine if the following series is convergent or divergent, and if it's convergent, classify it as absolutely or conditionally. Okay, so let's look if the series even converges. So I can see that this series right here, I know I want to use the alternating series test, so I'm looking. Let's plug some things in. So I plug in 1, and I get 1 over 2. Then I plug in 2, and that's a negative 1/3. 4, 5, 6. Okay, and it keeps going. And I can see that these terms decrease in absolute value, and they're getting closer to 0. So this converges by the alternating series test. Now we're going to go and we're going to get rid of all of those minuses, and we're going to look and see if I got rid of all of these minuses and I turned it into this series, what would that be over here? Well, it would just be this. And on this one, that is the same as basically here. If I started at 1 here, then if I wanted to subtract 1, I could add 1 here and just start at 2. This is a p-series, just an adaptation of where it started. But this actually diverges. And that was that absolute value of this in here is what that equaled. That's the absolute value of the a sub n. And this one diverges by the p-series. So since the original converged, but the absolute diverged, then this would make it conditionally convergent. Okay, let's try the next one. Determine if the following series is convergent or divergent. If convergent, classify as absolutely or conditionally. All right, so let's go see this one right here. I'm going to write it out. Okay, so at 1, that's going to be a positive 1. And then 2 is a negative 1 over 2 to the 1.5, and then 3, and then 4, 5. And here on this alternating series test, I can see that the terms decrease in absolute value to 0. So this converges by the alternating series test. So we know we have a convergent series. So now we're going to take it and look at what this would be if we took the absolute value of it. So it basically gets rid of the alternating part and we get it to here. This is another p series, and my p here is 1.5. So that is a condition, right? P is 1.5. So this one converges by the p series. So since our original series was convergent, and when I looked at that new absolute value series, it also converges, then I know that the very original series is absolutely convergent. Okay, so I do have to show you because I know that's fun to really understand what conditionally convergent means. So here, this is a true statement. This alternating series right here, if I added up all the terms forever and ever and ever, I would get the ln of 2. So true statement. So I know that this 1 minus 1/2 plus 1/3 minus 1/4. I'm going to write out some more here. Okay. So what would come next in that sequence? Plus 1/5, right? Minus 1/6, plus 1/7, minus 1/8, plus 1/9, minus 1/10, and we keep going. Okay, so I'm going to rearrange. And the way I want to rearrange is do a positive. So take that. I'm just going to rearrange the way I add. And then I'm going to put this one and this one down. So I'm going to do minus 1/2, minus 1/4. And then I'm going to take the next positive, so 1/3. And then I'm going to do the next two negatives. Right? It's mathematically okay to rearrange the way that you add numbers. And subtracting is just adding a negative. And I'm going to take the next positive with the next two negatives. And I'm going to continue that process until eventually I have checked everything off. And we're going to infinity, so we'll get to them all eventually. Okay, so then I'm going to group, and I'm going to look at these two together, which would give me 1/2. And I'm going to leave that one alone. And then I'm going to look at these two together, and I'm going to leave that one alone. See, I'm just rearranging things, nothing crazy. Look at those two together. And then leave that one alone. And I'm going to continue that process. Okay, well, gosh, you know what I want to do next? I want to pull out 1/2. Don't know why, I just feel like it. Ready? I'm going to take 1/2 out. That's okay to do as well, right? Mathematically okay. So that becomes 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5 minus 1/6 plus dot, 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 dot. Wait! Oh my gosh! Look at this. Are you ready? What was that? Well, that's just the original. All of that right here, right? That's just the original. And what do I know that's equivalent to? That inside is equivalent to the ln of 2. But wait, because ever since up here, I knew that this had to equal the ln of 2. This equaled the ln of 2, right? This equals the ln of 2. This also had to equal the ln of 2, and so therefore this had to equal the ln of 2. What? And then, well, I'm going to go ahead and divide by the ln of 2 and multiply by 2. And we've just proven that 1 equals 2. Okay, so that's conditionally convergent. You can rearrange to get a different sum, and then henceforth proving that 1 can equal 2. So cool. Hope you guys are like, minds blown. Okay, so back to what we'll actually see. But that's what it means to be conditionally convergent. So it says, which of the following are conditionally convergent? So see if you can look. These terms, when are all alternating series, they all decrease in absolute value to 0. So they keep, as I keep getting a bigger n, then the terms keep getting smaller overall. So they all converge. So I want to look and see which ones, when I take the absolute value and get rid and make new things, which one of these would also converge just by looking at the absolute values. Well, this one diverges by the p-series, this one converges by the p-series, and this one diverges by the p-series. See, on a multiple choice, it's kind of nice. You don't have to like show everything out. You can just use some shorthand here. So this would be absolutely convergent. So it's not this guy. So it would be these two converge, but the absolute value diverge. So they would be the conditionally convergent, which is C. All right, 2 more pages. I want to see if you guys can do this one by now. Go ahead and work this one out. See if you can get the statement that it's going to be. You can pause me and then unpause, but answer's A. Go see if you get that. Okay, so this one wants to know which ones absolutely converge. So this one, terms are decreasing in absolute value to 0, so I know that it converges by the alternating series. Same thing here, that one converges. Oh, but look at this one. This one goes to 1, which is not 0. I know that's just divergent. Okay, so that one's just out. And then this one, again, converges by the alternating series. So I know that A, B, and D are possibilities to be absolutely convergent. So now I'm going to go look at just these terms with the terms that are only positive, right? Because now we're taking the absolute value of them. That one diverges by the p-series. This one diverges by the p-series. This one converges. So I am absolutely convergent here. That converges by the geometric. Okay, last page. Which of the following series converge conditionally but not absolutely? I think that you can figure out that this one is absolute and this one is conditional. If you need help with those two, please, please, please ask me. Otherwise, pause and make sure you get those. This is the tougher one to think about. So I'm going to say they do decrease in absolute value to 0. So I know that this converges by the alternating series test, okay? But I need to know what happens to the absolute value of it. So I'm going to do a limit comparison test, or you can do the direct comparison test. Either way, I'm going to choose 1 over n. Okay, so 1 over n diverges. So here the limit as n goes to infinity. Let's see. Well, actually, I don't know if that one will work. So we're going to take the original. Oh, nope, that one's not going to be finite positive. That's going to go to infinity. So we're going to have to do a direct comparison test. So let's see, direct comparison test. This is smaller, which makes it bigger. Oh, look, and then the smaller one, which is greater than 0, diverges. So the bigger one also has to diverge by the direct comparison test. Because that diverged, it's the harmonic series by the p-series. Okay, so what was it? Wanted converge conditionally. So this one was conditionally, and this one was conditionally, so it was D. And if you need help with that, let me know, okay? This would be a really, really good one for you guys to try on your own and see if you get C. And I will help you if you don't. And similarly, I want you to try this one on your own and see if you get C. And again, I'll help you in class with those at the end if you don't, but I really want you to try these without just listening to me. So we'll come together and we'll meet if we need more help. Okay, there's the end of that day. Yeah.